Correcto. No.
Mm. Okay. Hello everyone. I'm Akanksha, and with me are Chinmay and Sarvarshit, and we are really excited to walk you through our journey in building a cloud-ready airline booking platform. Our project, Digital Transformation in the Airline Industry, focus on the digital transformation currently happening in the airline industry, particularly drawing inspiration from American Airlines and their collaboration with IBM to modernize outdated and monolithic systems. We've seen a major shift towards cloud native architectures, secure deployments, and user focused experiences in the aviation sector. So, in this project, we aim to simulate that transformation using modern technologies such as Python Flask, Secret Manager, and Google Cloud Platform. So, the main problem statement that we focused was so traditional airline booking systems have several core limitations. First, they often store passwords in very insecure ways, which increases the risk of data breaches and user distrust, something we've experienced firsthand with our corrupted password hashes. So, second, the systems are not built to scale. During peak travel times like holidays or flash sales, the infrastructure struggles to handle the traffic, causing downtime and loss of revenue. Third, operating with fixed infrastructure leads to high costs during off-peak hours and limited capacity when it's actually needed the most. So finally, the need for manual scaling and maintenance creates delays and increases the chance of human error. So our project addresses these issues by leveraging cloud computing. We use GCP services like Cloud Run for automatic scaling, Cloud SQL for managed databases, and Secret Manager for securing credentials, all of which support a modern, reliable, and cost efficient airline system. So, coming to the literature reference, we have reviewed multiple academic and industry sources to guide our architecture and technology choices. So, the first reference compared to legacy airline systems with cloud native platforms and showed that cloud native apps significantly reduce maintenance and improve uptime. And a Google Cloud Security white paper emphasized best practices such as using Bcrypt hashing for passwords, IAM roles for permission control, and Secret Manager to hard coding credentials. Another paper focused on serverless deployment like Cloud Run and functions. It showed that serverless systems handle much larger user loads at reduced operational cost, though with minor trade-offs like cold start latency. So we also looked at the cost optimization strategies on GCP, which showed up to 60% savings through auto scaling and managed services. And finally, we studied the importance of user experience, specifically robust data handling and authentication, which informed our design of login flows and error messages. Um, yeah, so the existing results will be continued by my teammate Varshit. To you, Varshit.
Yeah, yeah. Thanks, Akansha. Thanks for the thing. Yeah, hi everyone. I'm Sarvashit. We are working on the American Airlines, like as my teammate Akansha mentioned. So now I'm going to show, before going to show the existing results, first I wanted to show you with like in local how the application is running and what are the features we are providing. So as part of that, like first I'm opening my terminal. Yeah, the thing is like already, I mean, I have the code and all the things inbuilt. I have kept in my local the application things using Flask and Bcrypt. So for now, I'm going to run the Python AP app.py file. When I'm running the file here, the thing is I'm getting the application is started, and if I need to think, I can see it in localhost in Python or http.python. So here, if I'm going here, let me show you 1 minute. I'm sorry. Mm, Yeah, if you see here the user ID and login mounted. Before this, let's say we have 1 minute. I'm sorry. Let me copy it for better purpose. Yeah, here after going through it, here we have two options like user and admin. First, I wanted to go with the user because where we can book the flight tickets and know the availabilities and everything detailedly. So I'm proceeding with the user details. Here, after going through the user, we need to give our name and email ID and password. So at present, the thing I have given my as my of not with data Akash. So here, like I'm logging in. So if you can see after logging in, like we can see the dashboard. It's a basic dashboard like searching and the booking the flight, and as well we can see our bookings and we can write the feedback, and as well as we can do the log off. So first, I just wanted to go with the searching and the booking flight. So here, as you can see, like currently there's no flights available due to the thing as it's a basic application. So here like the date we can select our date, time based on our requirement. So like here we can say like I have randomly selecting 2:49 p.m. for tomorrow. So like from I just wanted to do from Hyderabad to Delhi. So I just wanted to search my flights. Actually, currently no flights available. So that's the thing. As we can go with another flight as well. Or else if I don't wanted to go with like if I go to dashboard and if I have any like if I wanted to see the bookings, do I have any existing bookings like thing if I wanted to say no currently no bookings due to like I'm a new user to the environment to the application. So that's the reason I don't have any bookings. If I wanted to write any feedback after this, like let's say nice journey or nice airlines, I can feel if I can submit the feedback and after that I can say like a thank you for the valuable input based on the thing. So this is the thing like how we are running the local application. Now I'm doing the logo. So as well like if we go back to our existing results as we discussed here, so here the basics on the based on the metrics wise, we are evaluating the results for the application. Like here, as we have the averaging first metric was average response time. Here the legacy is 2.2 seconds, and after the in our things in previously it have like 1.8 seconds, and the concurrent users like 1,000 or in our previous 1,000 upcoming time 95%. And security obviously we need password. It is such a shop and cost per month it is $1,500, which is legacy in on premise, I mean in local. Wherein coming to the cloud wise we can see like it is very less time or concurrent users or uptime, which was very cost effective. As you can see as in GCP very much it will be there, means we can see that the response time will be 9 seconds only, concurrent user 15,000 and uptime 99.95%. And security wise, it is both a Bcrypt and secret in the sense in cloud we have the secrecy. And cost per month is 3,350 dollars, which is very cost effective. This is about high level in local how we will run in local. Coming to the architecture of the project we have, as we know that it is a very application is we are migrating from local to on-premise, I mean to cloud. So as part of that, like high level overview here, we are using the Flask and SQL and cloud services for load balancing and logging analytics. When coming to the user browser or user interaction phase, here we are using the user browser which interacts with the web application via the browser, and after that a cloud load balancer. Here the users are requested through a cloud load balancer like that distributes incoming the traffic to available backend instances. So that's the reason here we are using. And after that, when application coming to the application background here, like using the Flask app as it is made backend, it is written in the Flask framework using Python language, and where it handles like routing, request processing, etc. And all of the things, many things which will handle. And inside the Flask, we have the MySQL and which will communicates with I mean Flask communicates with SQL, and as you can see in the diagram itself as in the arrow, and after that the databases for storing and retrieving, and stack assets for HTML, CSS, images, whatever it may be in front end, and API keys for pushing the I mean application uses API keys for securely doing the external APIs. And after that, as you can see like logging and cloud. Here we are moving it to the cloud. So here like log from the application errors, everything it will be collected, everything logs will be stored and analytics coming to further after complete thing, it will be process to the analytics team, that's the architecture. And coming to the we ask like it has some architecture implementation in the implementation stack entirely local and in cloud. The in front end we are using like as we know like HTML, CSS, JSON, and the UI is American Airlines. And back end we are using Flask API, which is REST API. Flask, Python Flask for REST-OK. And after in database, like in local, we are using MySQL. In GCP, we are using Cloud SQL. And for deployment, Cloud Run, which is OLS, we know. And security purpose, Flask, which is Flask Bcrypt, which will give the which will give the each and everything we need, like encrypted process and secret key access key, like that. It will provide security manager and IAM roles. We all know about it in cloud, which will give only the specific users. And monitoring, as we discussed earlier, like cloud logging and monitoring, both we can see here. So from next step, how it will be implemented in cloud and all of the things, my teammate Chinmay will explain it. Thank you. Chinmay, go ahead.
Yeah, thank you, Varshit, for explaining all of this. So, moving on here, hello everyone. This is Chinmay. So, I'll be taking you through the key technical steps that we have taken to enable the cloud native functionality for our application. So, here we have redesigned the Flask backend to be stateless, which is essential for our horizontal scaling in the cloud, which means there is no session data or user specific data which is stored on the server. Everything is managed via secure tokens and external services. And then we have implemented Bcrypt hashing for all user passwords using Flask Bcrypt, which adds a strong cryptographic protection, making it extremely difficult for attackers to reverse engineer passwords, even in the event of data breach. And then we have deployed to Cloud Run for auto scaling. That is a serverless platform which enables automatic scaling based on traffic, zero downtime updates, and reduced infrastructure management overhead, which is ideal for a modern scalable architecture. And then we have migrated our entire data to Cloud SQL with MySQL, which is benefiting for managed backups, high availability, and seamless integration with the Cloud Run, and IAM for secure access control. And lastly, we have integrated the cloud logging and monitoring to gain visibility into application performance and health, which allows us to set up alerts, analyze logs in real time, and proactively detect any issues in the production. Moving on to the next slide. So here we have shown a snippet, which is a part of a Flask-based login system using Bcrypt, which is just a small snippet from our entire script that we have. Here it is just which handles the user login request, which checks the password whenever there is a session from a user if he tries to log in, and with the proper credentials, it will be successful, or else it will throw an error. That is basically a part of the snippet that we have here, and all the code passwords are encrypted using Flask Bcrypt, and if there are any error, any invalid login attempt is done, then they will get an error. Corrupted password hash, which please reset your password or something like that. So that error message will be popped up, and we will show the actual implementation of this in Google Cloud. So yeah, for the implementation of it in Google Cloud Platform, we have used virtual machine VM for development and other testing phases. Here, where we are hosting our Flask application in a controlled environment, allowing us to use custom OS level configurations and manual other settings which are needed for serverless model, which needs to be run using Cloud Run. And then we have created a instance group with the name American Airlines Autoscale, which is used for auto scaling purposes, which we have deployed in our VM for which could be used for load balance of multiple instances of the app, which ensures high availability and resilience under variable traffic flows. So this is the Cloud Run. We will just run it and then show how our output would be there. And then it will take to our ticket booking page, which is very similar to the local instance creations. The exact application was moved to the cloud with all the functionality and with additional features of encryption of the password, and then auto scaling, which is highly managed with a serverless model with the microservice architecture. So we have got multiple advantages by using it. We will go through the slide which shows what are the results that we got using this model in the Google Cloud Platform. So here are our results, which says that average response time was reduced from 2.4 when it was in local to 0.8 seconds, which is almost like 68% faster. And peak concurrent users has also, the number has been raised. And the uptime is also almost in the GCP, it is like 100%, almost nearing to the 100% uptime. And there are no security incidents, which ensures that there is a complete secure cloud application. And also the monthly cost which is incurred is also has been reduced using the GCP cloud platform. Passing on to next slide, that here we have a small snippet where our application results are shown. Akanksha will be taking over from here.
Thanks, Chinmay, for explaining so clearly about the GCP implementation. Now let's talk about GCP dependencies table. So this table summarizes the Google Cloud services that power our project. So we use Cloud Run to deploy our Flask app. Cloud Run handles all the infrastructure provisioning and scaling, allowing us to focus on the code. Cloud SQL was used for relational database, storing user details, flights, bookings, and feedback. For security, all sensitive data like passwords are stored using Flask Bcrypt and managed with Secret Manager, which keeps credentials out of our code base. We also used IAM roles to enforce strict access control and cloud logging and monitoring to track resource usage and application performance. So this gave us full visibility into errors, uptime, and scaling behavior. Going to the next slide. So coming to comparison and analysis, this slide compares key metrics from our GCP deployment with the literature we reviewed earlier. So for authentication, we went beyond basic API keys by combining Bcrypt and Secret Manager, which offers easier key rotation and stronger password protection. In terms of scalability, traditional systems rely on manual scaling, while our Cloud Run deployment scales automatically. And this allows us to handle 3 times more users under peak load. Latency dropped from 1.8 to 0.8 seconds, and costs were cut in half compared to typical managed cloud deployments. Security also improved by using IAM and secret management best practices. So while setting this up introduced slightly more complexity at the start, the long-term benefits like automation, reliability, and security, these far outweigh the actual initial effort. So with the future scope, looking ahead, there's a lot of potential to expand and enhance this system. So we plan to integrate AI or ML using Vertex AI to offer personalized flight recommendations and predict peak travel times. We also aim to adopt a multi-cloud strategy by integrating services from AWS to improve fault tolerance and disaster recovery. On the security side, we want to add Cloud Armor for protection against reverse attacks and multi-factor authentication for user logins. For deployment, we'll implement CI or CD pipelines using Cloud Build and Artifact Registry to enable faster and safer updates. We're also exploring a mobile version using Firebase to make the service more accessible. And lastly, we plan to use Pub or Sub and data flow to enable real-time analytics and event-driven notifications for bookings and updates. So to conclude, our project demonstrates how a traditional airline booking system can be transformed into a secure, scalable, and cloud-native application. By using GCP services, we achieved faster response times, greater scalability, and stronger security, all of which align with the modernization goals of leading airlines like American Airlines. You'll find the link to our full demo and source code here. Yeah. Thank you so much.